Good morning. Today we are going to start 10th chapter of chemistry, that is S block elements. It's quite visible on the screen, a skeletal form of periodic table. The left hand side, extreme left, shows S block elements. S block elements contain two groups, group 1 and group 2. Its general electronic configuration is NS1 to 2. Means for the first group it is NS1, for the group number 2 it is NS2. Have a look on this picture also. It shows just a funny representation for you for learning or for keeping in mind the various elements of various groups and periods. As we are concerned only for S block, that is group 1 and group 2, so start from group 1 element. Hydrogen is considered as element of group 1 also, as well as for the group 17, but for the time being we are not considering it. Let us start from lithium, sodium, potassium, rubidium, cesium, francium. This is group 1, starting from the top to bottom. And then beryllium, magnesium, calcium, strontium, barium and radium, as the picture shows. Francium and radium, they are radioactive elements, and during our discussion of physical properties and chemical properties, they will not be considered. Let us start with S block elements. Elements in which the last electron enters S orbital are called S block elements. And elements of group 1, group 2. Group 1 is alkali metal, group 2 is alkaline earth metal. They give S block elements. The elements of these groups contains 1 or 2 electrons in the outermost S orbital, while all the inner shells are completely filled. Electronic configuration of group 1 may be represented as noble gas core NS1, while that of alkaline earth metal, it shows noble gas core NS2, where N is the number of outermost shells. Both alkali and alkaline earth metals are highly reactive and hence do not occur in the free state. Alkali metals similar chemical properties, yet they do not occur together, mainly because their ions are of different sizes. Some alkali and alkali earth metals occur abundantly in nature. Calcium is the 5th, magnesium is the 6th, sodium is the 7th and potassium is the 8th. Barium is the 14th and strontium is the 15th most abundant element by weight in the earth crust. Sodium and magnesium are also present in relatively large amount in seawater, brine wells and few salt lakes. The first element of a group differ considerably from the rest of the element of the same group. This anomalous behavior is due to number 1, small atomic and ionic radii, high electronegativity and ionization enthalpy, high polarizing power, absence of d electrons, and lithium differ from rest of the alkali metals and beryllium differ from rest of the alkaline earth metals. Now study about the diagonal relationship. Some elements of certain groups in the second period resemble with the certain elements of the next group. This is called diagonal relationship. Group 1 shows diagonal relationship with group 2. For the time being, it is said that lithium shows diagonal relationship with magnesium. Beryllium resembles aluminium. Similarity in electropositive character. Electronegativity increases along a period but decreases down a group. Electropositive character decreases along a period but increases down a group. Similarity in atomic or ionic radii. Atomic and ionic radii decreases across a period but increases down a group. On moving diagonally, these two trends partially cancel out. Now, similarities in polarizing power. On moving across a period, the charge on the ion increases and size decreases, causing the polarizing power to increase. On moving down a group, the size increases and the polarizing power decreases. Let's start with physical properties of S block elements. The group 1 of the periodic table contains 6 elements: lithium, sodium, potassium, rubidium, cesium and francium. They are usually referred as alkali metals. Their oxides and hydroxides are soluble in water and form strong bases or alkalis. Alkali metals are highly reactive and hence don't occur in free state. Lithium is the 35th most abundant element by weight in earth crust. Sodium and potassium are 7th and 8th most abundant element. Now study with the physical properties. Number 1, electronic configuration. Alkali metals are S block elements because last electron in them enters the S orbital. They contain only one S electron outside the noble gas core. Their general electronic configuration is noble gas core NS1, where N is 2 to 7. Second, large atomic radii. The alkali radii of alkali metals are the largest in their respective periods. These increases as we travel down the group because as the atomic number increases, the number of energy shells increases by 1 with each succeeding element. As a result, the screening effect of the inner filled shells on the valence s electron increases and electron cloud tends to expand. The distance between nucleus and last shell increases and thus the atomic radius increases with increase in atomic number. As the atomic number increases, the nuclear charge also goes up. This tends to decrease the atomic radii by attracting the electron cloud inward more forcibly. Large ionic radii. The ionic radii of the cations formed by them are smaller in size than the corresponding atoms because when the valence s electron is lost from the alkali metal atom, the monovalent cation formed one shell less than the corresponding metal atom. With the loss of one electron, the effective nuclear charge increases and thus the remaining electrons are pulled closer to the nucleus, thereby decreasing size of each individual energy. Low ionization enthalpy. The ionization enthalpies of alkali metal decreases progressively as we move down the group from lithium to cesium. The s electron to be removed becomes farther and farther away from the nucleus because of the addition of new shell with each succeeding elements due to an increase in the number of inner shells. The screening effect also increases. The second ionization enthalpy of alkali metals are very high when an electron has been removed from the alkali metal. The resulting monovalent cation has the stable noble gas configuration. Since it is difficult to remove an electron from the stable noble gas configuration, therefore the second ionization enthalpies of alkali metal are very high. The hydration enthalpy of alkali metal ions decreases with the increase in ionic radii. Lithium positive is greater than sodium positive, is greater than potassium positive, greater than rubidium positive, greater than cesium positive. Because of smaller size, lithium positive has maximum degree of hydration. Now what are unipositive ions? The alkali metal exhibits oxidation state of +1 in the compounds and are strongly electropositive in character. The electropositive character increases from lithium down to cesium. Because as the alkali metals have low ionization enthalpies, they have strong tendency to lose the single valence electron and therefore it gives M positive and it releases one electron. Now let us start with metallic character. The tendency of any element to lose valence electrons to form positive ions determines its metallic character. As alkali metals have low ionization energy, they have high tendency to lose valence electrons. So they are typical metals, and metallic character increases down the group. Metallic character increases down the group. Now melting and boiling points. The melting and boiling points of alkali metals are very low and decreases with increase in atomic number. Because as alkali metals has large size, the intermetallic bonds in them are quite weak. Hence they have low melting and boiling point, which decreases down the group. Nature of bonds formed. All the alkali metals form ionic compounds because alkali metals have low ionization enthalpies. Density. The densities of alkali metals are quite low as compared to other metals. Lithium, sodium and potassium are even lighter than water. These densities increases from lithium to flame coloration. This is very important point. All the alkali metals and their salts impart a characteristic color to the flame. On heating an alkali metal or its salt, especially chloride, due to its more volatile nature in a flame, the electrons are excited easily to higher energy levels because of absorption of energy. When these excited electrons return to their ground state, they emit extra energy in form of electromagnetic radiations, which fall in the visible region, thereby giving a particular color. Photoelectric effect. Alkali metals except lithium has photoelectric effect. Because due to low ionization enthalpies, alkali metals, especially potassium and cesium, eject electrons when exposed to light. Lithium, which has the highest ionization enthalpy amongst the alkali metals, cannot be used in photoelectric cells because it does not release electrons when exposed to light. So that's all about the physical properties of group 1 elements. So all the very best, and this chapter is very easy also. Prepare it. It will be very helpful for moving with P block elements also.